So what is Vagrant? So Vagrant's job is it abstracts away the hypervisor, and it stuffs all the configuration into a single file so that you can bundle that with your applications. It's an open source tool created by HashiCorp. They've also created some other well-known tools like Terraform that some of you may have heard of that's used for provisioning and destroying cloud environments. Out of the box, it supports VirtualBox, Hyper-V, and Docker, but it supports a bunch more through its pluggable system. It's pretty neat. So you primarily interact through Vagrant through its configuration file and the Vagrant command, and we'll go through some examples of that. So just some quick configuration notes. You have to install Vagrant in a supported hypervisor. I'm going to use VirtualBox and not Hyper-V, and Windows folks are kind of surprised about that. But the real reason for doing that is that this gives you cross-platform support. So when you spin up a Windows box inside of VirtualBox, that means that someone on Linux or Mac can use it with Vagrant, since Vagrant is cross-platform. The other advantage is because VirtualBox is the first hypervisor that Vagrant was written to work with, there's a much broader selection of images that you can download. So if you have hypervisor installed, and since you're a PowerShell person, you probably have it installed on your laptop, you can create a dual boot configuration. Scott Hanselman has a blog on how to do that, and there's links to that in the materials and how to do it. Another quick note, Vagrant supports colors on the command line. So when all that text is flying by, it can be in different shades of gray and occasional green. It's nice when you're spending a lot of time there. If you have the Windows 10 Creator update, you just need to add an environment variable, Vagrant Force Color, and it'll turn all that on for you. So really, that's all the slides. Now it's all demo from here. So let me switch off and share my VS Code window. All right. Close PowerPoint. All right, can you guys see that okay? Can you see it at all?
I think it's a black screen.
Of course it is. Okay. I'll try to share the window again.
We can see you now. Probably good.
Yeah, I'm trying again. Anything?
Okay. I see the top of the window, looks like.
Was there?
That's not good. All right, so
Visual Studio Code, and it's black.
it's black. Can you read the text?
No.
No, the whole thing's black. We see but everything else is black.
All right.
It's a black dog in the middle of the night.
Okay, so let's try a different approach then. I can try and pivot and do this in the ISE, but it's going to be a little chunky. Let's see how I get, and it's untested because why not? I'll tell you what, let me make this my Visual Studio window a little smaller.
See why I don't play Visual Studio?
Live demo for the win. What can go wrong?
No, it's what can go right and what can Visual Studio. There, I see something.
Can you guys see that now?
Well,
There we go.
hey, there we go.
Yeah.
Is it readable?
Probably want to make it a little bit bigger.
All right.
We've got a window and a window going.
A very cramped window with very big text. All right. So get rid of this and get rid of this. So I've got a few different scenarios, and we'll kind of get a little more complicated as we go. So the first one here is just to create a base Vagrant box. So how Vagrant works is it's going to pull down images from any URL you want, really. But HashiCorp allows you to store your boxes for free on their website. So create a new box with this command here. So that's gonna check. So create this new Vagrant file in this directory, and that's not where I wanted to create the Vagrant file. All right, let me switch to my demo directory. All right. Okay. So now we've created this new Vagrant file. So Vagrant file, it's a Ruby configuration file. And I'm sorry, guys, this is going to be, my window's a little smaller and text a little bigger than I had before. But you don't have to know Ruby for it. You're fine without it. And really, this is the boilerplate that it'll create for you. So you see almost everything is commented out. So all it has in here is just referencing this one line, which is the image that we're using. So how this will work, I'm going to run Vagrant up. And if this box is not in the system, then it would download it. Of course, I do have this on my local machine, and it'll spin up and provision the machine. So we're going to run Vagrant up.
So do you want to maybe talk a little bit about what Vagrant is for those of us that have limited knowledge of what it is and why we want to kind of use this?
Yeah, and that's actually what I'm doing here when this comes up. I'll be able to walk you through what it's doing and why it's doing it before we get too far down the rabbit hole. So Vagrant, it abstracts away the hypervisor. So it sits in between you and whatever hypervisor you're doing, but it gives you a way to store configuration files in a way that can be easily packaged and shared with other people. So this Vagrant file that was created, this is pretty basic, right? But you can have, it'll run scripts and provisioners in line that can configure the box for other folks. So you can bundle this Vagrant file with a project, or you could have a folder that's a Vagrant project that has a Vagrant file in it that you can easily share to do things. And this is important, of course, a lot more slowly than it did every time I tried it before. So what this is doing now, this is copying an image from my local machine, and it's going to import and spin it up. So images are typically built with a tool called Packer, which is another HashiCorp thing. So Packer is an executable file, and it can read Windows unattended text files, has a configuration document that points to Windows unattended text files, scripts, and that sort of thing. So it can actually take an ISO, boot it up, build the image, and save it off, and then upload it to Hashi's cloud for you. And so for this purpose, I'm using the 180-day copy Windows, 180-day Windows evaluation licenses, so I don't have to pay for Windows Server. The license activation is from when the machine was created, though, and not from when you first spin it up. So what's happening here? This image that's already been downloaded. It was copied in. It's setting up port forwarding so that for remote WinRM and remote desktop and SSH, even though there's no SSH on this machine, and it's booting up. So right now it's waiting for WinRM, for PowerShell remoting to become active. So how this is going to work is inside of the VM, and over here I've got a Windows Server desktop coming up. So the server's booted, so it's waiting for WinRM to connect, and it's going to handle all the configuration of the machine from inside of WinRM. So it's going to connect to the box, and it's going to create a shared folder inside of Vagrant. This will make a lot more sense when I actually get the machine here. All right, so the machine is now online, so you can see it now, the shared folders. So okay, so this folder that said it mattered. This is the folder we're sitting in right now. So this would be your PowerShell module folder, or whatever your live demo. I just ran Vagrant up again. It'll blow through fast, so it's already online. All right, so now that the machine's online, I can run Vagrant PowerShell. I can actually PowerShell into this VM that I just spun up. And if you look back inside the machine, we've got this Vagrant directory. This is the Vagrant shared folder. It's mounted at C Vagrant on Windows boxes, and it's /Vagrant on Unix boxes. So here's the Vagrant file, the readme.md. So you can see this is all the same stuff. Can you guys see my mouse as I'm pointing at stuff?
Yes.
These are all the same files that are in this folder that's shared. So this is a pretty simple example. So we just spun up a generic Windows box from scratch. We've got it live, and we've got this shared folder. I do want to show you something with the Vagrant shared folder. So I'm going to share the desktop here. All right. So it is customary for Vagrant boxes to have a Vagrant user where the password is Vagrant, because these are intended to be development boxes and not anything that's super secure or whatever. So first login. And we look at this Vagrant shared folder. You can see it's not a natively mounted folder. So what they've done, sorry, just VirtualBox just resized the window for me. What it actually does here, it creates this internal SMB server, this VBox server / Vagrant share. So depending on what you're doing, permissions can get a little bit goofy sometimes. If you're using Hyper-V, it actually requires you to create a share on the host, and Vagrant will map into it that way. So back to VS Code. All right, so this is just a basic example to show what Vagrant is. We spun up a machine, we can communicate with it, we can interrogate it. So let me get out of the machine. You can shut it down with Vagrant halt. You can run Vagrant provision, rerun any provisions. We don't have any of those set up yet. I'll show you those in the next step. And Vagrant destroy to just kill the VM. Okay, so in this next one, things will get a little bit more interesting. So in this one, the Vagrant file has a few more things in it. So it's a Ruby configuration file. So inside of a variable, we've got a script being stored. And if you notice, because it was Unix first, you have to escape slashes. So single slash ends up being a double slash. We've got the box name like we had before inside the configuration. And then we've got some provisioners defined. So script inline, we're just going to run get date, and we're going to dump it in that file. This one is running this script that's defined up here. This provisioner is actually going to run provision.ps1, which isn't doing anything fancy, but just to say that Vagrant created this file on this date. And this last one does something similar, but we've got the provisioner set to run always, and that actually makes a difference. So I'll show you how that looks. We're going to Vagrant up this box. It's a similar scenario to what we had before. Machine's going to boot. It's going to copy it into the folder if it doesn't have it already. It's going to run the script provisioners when the system comes up, and then we'll poke into the box when it comes online and see what we got. You guys tracking me so far? Do you have any questions?
Alex, I have a question.
Yeah.
Where did the operating system come from? Were you saying that that's stored somewhere on the cloud, or can you download an image and prepare that?
Yes. So the way it works is you can create Vagrant downloads pre-built images for whatever your hypervisor is. You can store them for free on Vagrant Cloud, and I'm using the 180-day Windows evaluation licenses. You can build those boxes with a tool called Packer. So you can have some infrastructure, so you can have Morse code that builds even the image in the first place. And between the two, Packer is really, as an aside, where something that you would use in your production environment. Say you could use Packer to build AWS images that are already patched every month. So I use a Packer template created by Matt Rock, who works for Chef, and I build that on my own and upload the box to Vagrant Cloud so that it's always updated and available for me. And I try to do it once a month. In reality, it tends to happen about once every 3 months or so for me. But that's where the images come from. So it'll download it the first time, just based on this name being specified in the configuration file, but it'll store it on your box. So after that, for subsequent machines, it'll just copy it in. So where we're at now, the machine is spun up. It's set up these forwarded ports. You can also set up additional forwarded ports. So if you set up a web server, you could forward that back. So you could hit localhost port 80 on your machine and have it, load a web server inside of your VM. So the server is booted now. Vagrant has a timeout for the WinRM. It's waiting for it to become available. As soon as it does, it's going to connect, and you'll see it run the provisioners here in line to do some basic configuration of the machine.
So it looks like it says WinRM username and that it's going to connect on that generic user account. So is it going to start invoking things? Vagrant's going to start invoking commands using WinRM inside that
Right.
image as it stands it up?
Right. It's going to run. So the Vagrant shared folder, that C Vagrant folder, is now everything in the script provisioner 2 folder here, right? So provision always, provision1.ps1. This actually exists inside the VM. So what Vagrant is doing is it's going to connect to the VM and run those scripts inside of the directory here. So you can see it's mounted the shared folder, running the first the shell, the one that was inline here. It's running the other one, and then running the external provisioner. These are the 2 scripts that we wrote. So just to show that it worked.
And what's the difference between an internal and an external provisioner again?
So this is an internal provisioner. This script has just been stuffed into the Vagrant file itself. It's kind of nice in that you only have one file to deal with. But the downside is I have to escape all these characters, and if you have a big, long, hairy script, it's not going to feel right, stuffing it inside that file. Although you could. So just to show different examples, I've got examples of both here. So we've got this. So I'll run them again. So you've got this internal provisioner that just ran get date out file, and that creates this Vagrant was here 1.txt. So if all we did with this provision is we created these 4 text files. Here's the first one. Right, so this is just what this command ran, this get date, and we dumped the file out here to Vagrant was here 1.txt. This next one is running this script variable that's inline, which is what's defined here at the top, which is really just these lines. So something similar. So it should say let there be file IO in that file. Right. Then we've got the 2 external provisioners, provision.ps1, which wrote the 3rd file, and provision always.ps1. And there's a difference between these that I'll show you guys in a second. So this ran that provisioner, wrote this 4th file as well. So you can see when the file was updated, yada, yada, yada. Okay, nothing too crazy there. So these, you can see that they were run in line based on the timestamps inside the file, all fairly close together. Now, but because this last provisioner was different, this one's set to provision to run always. The big difference there is going to be that this is going to run every time the machine is restarted. Those other provisioners are only going to run the very first time the machine is spun up. So if we do a Vagrant reload, we'll just reboot the machine. And we'll use Vagrant commands to do all the reboots and everything because it allows Vagrant to know what's going on and to remap that drive and everything when the machine comes back up and keep track of what's going on. It's going to shut down the VM, spin it back up, and you'll see that only this 3rd provisioner runs after it reboots. So it's running provisioner shell. You can see it's running the provisioner always. It didn't call the other ones. And if we peek inside the VM, you can see this file was just updated. If we look at all of them, these other three were not. They're still have the time from the machine was initially provisioned. And those first three provisioners, because they don't have that run always, would not get run again unless you manually call the Vagrant provisioner like this.
And that starts and builds a whole nother VM over again, right?
No, so in this case, the VM actually stays online. It's just going to rerun the provisioners.
Okay.
So no reboot, no nothing. It's just going to rerun the provisioners. So this is kind of useful if you're using if you're playing with DSC or whatever, and you want to rerun your configuration over and over again. You can run Vagrant provision without having to reboot. Make things a little bit easier. So now, if we check out inside of VM, and I ran Vagrant provision instead of Vagrant PowerShell, so we're doing it twice. Nothing like live typing. Now, in this case, they've all been updated because we ran Vagrant provision. So it ran all the provisioners, including, and not just the ones that say run always. So does that make sense? Okay. All right. So in the third example, actually, a couple more things to talk about. So we're just using the script provisioner here. Vagrant comes with provisioners for different technologies inside of it already. So it's got a chef provisioner in it. It's got a puppet provisioner in there. So if you've got those agents on your image, you can just point it at a set of configuration files and it knows how to run those. There's a plugin DSC provisioner that somebody wrote. I was using it for a while. It's pretty cool, but on this last round of updates for me, it actually started breaking Hyper-V or Hyper-V with Hyper-V. Started breaking VirtualBox. So I'm just using the script provisioner for now. All right, so I'm going to destroy this VM. All right, and this next one, I'm going to cheat a little bit. So this is going to do a DSC configuration. So I've got, like that other example, I've got a couple of internal scripts. So this script is inside of the Vagrant file, right? This script .sources the DSC configuration. I'll show that to you in a second. Captures gets configuration directory, runs the DSC config, runs the DSC provisioner, and then afterwards, I have a little script to just, so this DSC config is installing a web server. So it's just going to do invoke web requests against the web server and just see that we're getting an HTTP 200 back. So you can see down here in the Vagrant files where we're going to run the DSC script and the verify script after the fact. Here's my DSC configuration, nothing too fancy. So we're just using the out-of-the-box PS desired state configuration resource, installing the IIS web server thing, and then I'm setting some file content so that it wouldn't deliver the default IIS page. Now I'm cheating a little bit here because this image uses, it's a thinned out image, meaning all the Windows features have been stripped from the image itself to make the initial download faster. So when you go to install a Windows feature, it has to download them from Microsoft using features on demand. So to avoid that, I actually spun it up before, so I'm going to have to run the provisioner myself to show you guys. All right, so folder, we got our Vagrant file, we got our DSE config. So I'm going to run Vagrant up. And the provisioner is not going to run here because I do not have either of these set to run always. But if this was the first time that I'd actually spun this machine, so if I did a Vagrant destroy and a Vagrant up, it would do the whole download and everything of this. So machine's booted, we're waiting for WinRM. And rather than connect to the machine right off, I'm just going to run Vagrant provision as soon as it comes up to rerun the DSE config. All right, everything's mounted, so we'll run Vagrant provision. So there's the DSC configuration running with all the verbose stuff. And then here's the verify script checking web server. And here's the result with the headers. So this little configuration spins me up a web server, which is kind of a neat way to go. If you have I have a more complicated build that I have for a lab for .NET Nuke that I'll use. And it's kind of cool because you can give somebody on a Mac or Linux their own copy of .NET Nuke running to experiment things. .NET Nuke is a open source Windows .NET CM content management system for websites. All right, so you set the machine down with Vagrant halt. Did all that make sense?
Yeah.
Yeah, speak up if you guys.
Yes, it did, Alex.
Yeah, I can hear you. Just speak up if anything gets confusing or whatever, because I can't see anybody's faces, so it's sort of hard for me to. I can't cue off confused looks or anything. Okay. So, in my next example, it's pretty similar to the last, but this is a case where it's rather than having my config run inside of the VM, in this situation, we're actually going to run the DSE configuration locally and generate the MOF file outside of the VM on our box. So this is good if you were doing module development on your local machine, you had something in your path, you want to run the DSE config on your box for whatever reason. So it's pretty similar, except there's less in here, right? Because all we need to do inside of Vagrant now is just run start DSE configuration with the path for the MOF. And then I have the same little script to just check to make sure that the web server came up. It is the same DSE config as before. The only real addition is I gave myself this generate MOF script that I can run so that I don't have to live type all that. So run the generate MOF script. So we've created our got our local host MOF file. It's been modified recently. So I'm going to run Vagrant up. And like the other example, because I don't want to wait for everything to download while we're on here, and I don't want to compete with stream bandwidth, the box has already been spun up once, so I'll run the provisioner again after it boots. Now, one thing I'm not going to cover here, mostly because I haven't tried it yet, is Vagrant can also do multi-machine configurations. So you can have multiple machines. You could build like a whole MCSE lab for yourself that you distribute with a text file. That's pretty neat. I'm going to run the provisioner. Got DSC running. Hit the local web server, shows that it's online. Does that make sense? You guys understand the difference between this one and the last one?
Yeah, I think so. Hey, Alex, can you see the questions in the Hangout?
I can now.
Okay, I think you had a question there.
So Vagrant's installed locally in your laptop and passing commands to VirtualBox to work with the image. After the machine is up, you're then configuring using WinRM. That is exactly correct. That's exactly what's happening. And the strength of Vagrant is that it's only really a handful of text files. It makes this pretty easy to distribute. It's a great way to build environments for your devs. Especially if you're using configuration management stuff at work, you can use those same configuration management scripts to build portable labs for them. It's a nice boost. But for me, I like to use it for my PowerShell development stuff. So here's an example where I've got a PowerShell module folder. Now, and this is something I didn't talk about before. See this Vagrant folder here? This is where Vagrant is tracking its status of the machine it has online and what the process ID of VirtualBox is and all that sort of stuff. So I exclude that in my git ignore file, all those Vagrant files, so it doesn't get checked into version control. Just something worth mentioning in passing. So, okay. So here's a PowerShell module example. So we've got a PSD1 file, just a GUID, nothing that interesting in here. A really simple module that just adds 2 numbers. Right? So add number, first number, second number, add them together, export all of our one functions. And then I've got some Petzer tests in here. So it has a module manifest, and it adds a number, and it doesn't add letters. So if we look at the Vagrant file, this one has a little more going on because there's some voodoo to get this into the PS module path on the host itself. So a couple of internal scripts. Well, first off, so here's a variable where I have the name of the module. I'm doing this so that Vagrant inside of the VM knows what the name of the module is so we can link it up farther down these scripts. And you'll see that in a second here. So here I'm installing NuGet and trusting the PowerShell gallery so that I can then install Pester. And then here is the module to create a symbolic link on Windows. And so a symbolic link is something that Unix folks use all the time, but isn't as commonly done in the Windows world. And I think a lot of folks don't even know that you can. So in a file system, every file is a hard link, right? A file isn't actually the data, it's just a pointer to where on the disk that data lives. So in Linux, you can have multiple hard links. So you can have multiple file names that actually point to the same data on disk. Or you can have a symbolic link that points to another pointer. So it's kind of like a shortcut to a file. So what this little script does is going to get the first folder out of the PS module path, because I really don't care for this purpose if it's a system path or the one under my profile or whatever. If that folder doesn't exist in the event that it's the one under my profile, this machine that we never logged into before, it'll create the folder, switch the directory, and it'll make the symbolic link with the mklink command. So mklink is actually part of cmd.exe, so you can't call it directly from PowerShell without calling cmd first. So it's going to run against the destination of the link, which is this args thing. So that's what's being passed in the first command line parameter. I'll show you that below. And the target of the link, which is that C Vagrant shared folder, which is our module. So how this ends up manifesting itself down here is, so we've got the box configuration, install our dependencies, create the symbolic link, and then we'll run pester. So let's spin it up, and I'll show you what that looks like inside the VM. So for this one, because I'm not installing a whole lot of stuff in here, I'm not doing any DSE. I'm going to go ahead and just and let it boot and do its import thing. Let's see what else. Are there any other questions while this thing boots? It'll take a minute or two. Okay.
Is it possible to interact with the GUI at all with Vagrant? Let's say you're installing something that has a graphical interface. Can you emulate mouse clicks and things like that, or is that like not what it's?
I suppose you probably could, but you wouldn't see it. If you could run a tool from PowerShell that emulated mouse clicks and stuff, so if you could do it from PowerShell remoting, that no, I'm gonna say probably not, because you'd have to run it from remoting, because everything that Vagrant does on the outside is going to be over WinRM. And I mean, and I suppose it depends on the tools, but I can't imagine those would work in those cases from the GUI. Now, you certainly could provision yourself a machine with all those tools installed that was built the way you wanted it, and then log in and run it. That would be a way you could go.
Did you see that chat, Alex?
So if I were using Vagrant as part of a building pipeline using, say, Jenkins, I'll install Vagrant on my Jenkins slaves. Yes. Yeah, you would. I haven't seen it done before. And I thought about trying to put together a demo, and I kind of ran out of time. But yeah, I think that would actually work. And you run your test, and you have this Vagrant shared folder, and anything that you write to see Vagrant inside of your VM will end up in this folder outside. So you could have your nunit.xml get dumped out there and get picked out later. And in this case, I'm going to spin this up, and I'm going to run PowerShell stuff. I'm just not consuming NUnit like Jenkins normally would. Yeah, I think you could absolutely do that. So let's create our symbolic links, and now it's going to run pester. And all of our tests pass. And just to poke around inside the machine a little bit. I did it again, guys. Sorry.
I was going to ask, did you mean to type PowerShell there?
I did. I didn't sleep a whole lot last night, so I apologize for my muscle memory taking over. I was doing some work with Vagrant on a internal PowerShell module at work yesterday, so I was running Vagrant provision a lot to run my tests. So it's okay. So Vagrant PowerShell. All right, so go back to the Vagrant shared directory. So again, this is all the same stuff that was in the folder outside the VM to include the Vagrant file, test files in the module. But because we did the symbolic link, if I switch to Got this Vagrant demo folder here. This is actually all the same stuff that existed in that other folder. So got foo.txt. You can see that it's now in the Vagrant shared folder, and it also popped up out here in the editor. For day-to-day PowerShell module development stuff, I think of all the examples, this one is the most useful. Again, this one's kind of bare bones, but you could easily call some DSE stuff. You know, and then one of these startup scripts, you could clone down a DSE configuration off of GitHub and change to the folder and run it, so you wouldn't even have to carry all that around, you know, in the same code that you checked in. This last example is a little bit less useful, but it's playing a few more games with symlinks. So it's similar to the previous example, except the intent is also to create a symbolic link outside. So this is a situation where, say, you were developing a module and you didn't want to ship it with your Vagrant box for whatever reason. So I've got this my module folder with this fake little dinky module here, and our Vagrant shared folder doesn't have much in it. What I'm going to do is I'm going to create a symbolic link bear with me while I copy and paste the command here. I'm going to create a my module directory in this folder that gets linked back out to that my module folder on the C drive. Oh, and that has to happen elevated, so I'm going to do this in the window off to the side here. Okay, so that was just created. So now we've got a symbolic link. So this is the same folder that was under C, source my module, and now it exists inside the Vagrant shared folder. So if we look at the Vagrant file, this runs the same script, more or less, to create the symbolic links out, except the line where I'm creating the symbolic links a little bit different, in that now I'm going to link out to a subfolder off of the Vagrant shared folder instead of to the full path. So if we run Vagrant up, I think this one's a little less useful and more complicated than the other example, but I thought it was worth calling out.
So by default, are the files shared between your host and the Vagrant VM, or is that something you always have to configure some sort of link between them?
So you get the Vagrant shared folder for free.
Okay.
So Vagrant will add the Vagrant shared folder. You can configure additional folders though. Does that answer your question?
Yeah. So as long as I put stuff in the Vagrant folder and then I do Vagrant up, the files are already there. I don't have to copy them into the
right. And it uses whatever file sharing system that that hypervisor uses. On Hyper-V, it actually will share out that folder on your host machine, and then Vagrant from inside the guest machine will map a drive into it to pull the data. VirtualBox is a little cleaner here. So see how this says fix port collision for blah, blah, blah? It's doing this because I never shut down the other Vagrant box that I had. So rather than having 2 ports mapped to 5986 on my local machine, it fixed it. So I can have multiple boxes going and it handled that. Now it's waiting for it to come up, and it's going to connect via port forwarding to itself, and we should have that PowerShell module in the path. Let's see, there's another question in the room. Another question, I think you already answered, but the PS scripts, whether internal or external, are copied into the VM. This is done via the shared folder. Yeah. So, well, the internal scripts, this actually isn't copied into the, well, this is part of the Vagrant file, and the Vagrant file is inside the VM. But I think what Vagrant is doing, it's just reading these into memory and then running them over WinRM. Whereas the external ones are mounted inside of the shared folder, just because Vagrant shared the Vagrant folder with the stuff on the inside. So Vagrant's mounting this folder that we're working out of here as C Vagrant inside of the host. And like I said, you get that for free. Whatever folder the Vagrant file lives in will get shared with the guest.
Are you seeing that other question there?
Yes. If I'm using Vagrant with Hyper-V or VMware, are you saying that Vagrant must be installed on the hypervisor host? Yeah, so this is, and I know you're thinking about those Jenkins examples. Vagrant's use case is really, more for local development. Although, like I said, I think you could do it that way. But yeah, I think the expectation is that it's going to be able to run the command line tools from whatever host that is. Now, there is an AWS provider, so it depends on how somebody wrote it, right? Because if there was good tools that called an API for that system, it would be possible for Vagrant to interact with it. I'm not aware of a Vagrant build for VMware ESXi. They have one for VMware Workstation, but I haven't tried that because I think that's actually a value add offering they want you to pay for. But I think that AWS would actually be a really neat use case, especially for like the CI Jenkins stuff. Okay, so we're up. I'm going to run Vagrant PowerShell and not Vagrant Provision. And hopefully this all works out as intended because I put this one together right before the session here. So switch back to my local PowerShell users directory. You can see my module is there. So again, this is kind of, if we follow the chain, this is here, but it's actually really here. But it's actually really in another folder on the host machine. So it's just been kind of mapped over multiple times. Again, kind of a bit of a hack, but worth exploring.
Yeah, sure. Go ahead and ask.
Hey, kind of question. You run the VM. I mean, how's the timestamp? It seems like you got the date, but the times are running all over.
Yeah, is it using the time of the guest, Alex? Or
Yes, yeah. So I'm not setting a time zone in that image. So it's whatever came out of the box, or whatever it synced. So yeah, I'm. This is using the time in the guest. I could change it. I could set a time zone, and then I'm sure it would all be synced over. Yeah, and that's exactly what it is. It's Windows, right? So this is Seattle time. No, that's backwards.
Yeah, that's backwards.
Yeah, that's in Atlanta somewhere.
So and it's not even UTC. I'm not sure what the default is. So you could set the time zone in the image. Not something that I bother to do, because these are the idea is that these are temporary machines that are torn down. But if it was important to your use case, yeah, absolutely, you could set the time to whatever time zone you wanted, with a DSC resource or a little script or whatever.
Alex, it looks like it's UTC time because it's +4.
That makes sense. Okay. All right. That's all the demos that I have. Do you all have any questions?
Alex, what's the coolest thing you've used Vagrant for?
The coolest thing that I've used Vagrant for, or the most complicated thing anyway. Let me turn off the screen share here. is I've got out on GitHub a project that downloads and installs .NET Nuke. I did this because, and I'll go ahead and share my web browser window here. I did this really because I wanted an excuse to learn DSE a little bit. Refresh because I hadn't touched it for a while. So this, I've got, in this project, I've got a Vagrant file. In the Vagrant file, I still got some of the boilerplate in here. But really, there's not even as much in here as there's in some of the other examples I showed you. There's just setting memory and changing the way that it resolves DNS with some VPN providers. That if they remap your DNS, then VirtualBox got a little confused. So this is telling it to use like the internal resolver on the host OS instead of trying to just go out and query itself. But really, so all I do though is I run this provisioner here, and then I run an inline DSE script up here, which is similar to the stuff that I showed you, which just kicks off a DSE provisioner, copies some stuff in. But where it's more interesting than the other examples is there's a fair amount of DSE here. I've got a lot of composite configurations. So this builds two websites, downloads SQL Express, installs it, installs IIS, configures permissions, and configures permissions inside of SQL, spins up, downloads 2 different versions of the .NET Nuke CMS, dumps them into the folders, and runs the DNN installer. I do this so that I can have a DNN build up and running frequently. And it's kind of nice too, because I'll be asked to give .NET Nuke builds to the people on a different platform, and someone running on a Mac or on Linux, they can install VirtualBox and they can install Vagrant, and all they have to do after they've done that is just download it and run Vagrant up, and they get that lab on their machine.
So the main reason we wanted to bring this up is it kind of solves that ever evolving challenge of, well, it works on my machine, but then you got to deploy it and it doesn't. Yeah. So you can manage your dependencies, whether they're dependencies on pieces of software, other PowerShell modules, things like that. So this is probably more on the expert level spectrum, with like the super continuous integration, continuous delivery, DevOps-y type stuff that we talk about. So you're going to see people that are pumping out a lot of PowerShell modules and stuff try to adopt this into their like build process and testing process. But it's, just kind of another step on your journey is, you go from writing just basic PowerShell scripts to PowerShell functions, then advanced commandlets and help, and then tests. So this would be like the ultimate end game where you want to get to is that, you want to test your module. That you have a Vagrant box that is completely agnostic to the environment, that comes up brand new, fresh every time, and you load in your dependencies and everything. It comes up, it tests your code, and then you know that it's ready to go before you put it into production. So just yet another guardrail before you release it out to production. So you know that when you put it out there, it's going to work.
Yeah, and but even on the non-advanced end, sometimes like you're writing some commandlets or whatever, and you just want to test them in a server OS. And I think a lot of admins are guilty at grousing at their devs about wanting tons of access to production and not testing things and everything, and then turning around and, well, I'm writing this PowerShell script and I think I've got it working, so let me run it in production real fast and see how it goes. And this gives you a good way to get a lab. It's also a great way for you to get a chance to learn those configuration management tools, because you can get a lab going for yourself really, really fast. And you start building out that DSE config, and the amount of Vagrant you actually have to know, is really, really small. All you have to do is just get to call in PowerShell, and that's it. It's also a really good way to learn Chef.
All right, quick one.
Sure.
If you have 2 VMs up with Vagrant at the same time, and you want to get into it with PowerShell, how do you switch between the VMs when you do your Vagrant box?
Okay, that's actually a good question. And I think that I have 2 VMs up still so I can show you. I'm just double checking here off screen to make sure which ones I have. Okay, yeah, so let me share my VS Code window again. Okay. All right, so it's all based on the directory that you're in. Vagrant is going to look for that information on the folder you're in, and it's tracking a lot of that stuff under that .vagrant folder. So I've still got this VM up and online. So if we change into that hidden folder, normally we don't care about the weeds, but it knows what machines it has up here. And it's tracking all kinds of stuff, about that box and what to do. So to answer your question, you'd have to make sure that you are in the folder with the Vagrant box that goes with it. If you had a multi-machine configuration, then you would specify a name. And I didn't demo that, but you can, when you configure the names of these machines. So when you configure these machines, you get the image name. You can also configure, there's a VM.box, and I believe it's .name. I'd have to check the documentation, where you can name the machine that you're setting up here. So you can use a switch on the Vagrant PowerShell command to specify the one that you want to connect to. In this case, I've got 2 different Vagrant machines up in different folders that aren't talking to each other, that aren't part of the same Vagrant project. So I do Vagrant PowerShell here. And we wait. I get this machine. And I switch to the other project folder. And I'm in a different box.
I think you had another question in the chat, Alex.
My use case, I need to spin up blank VMs while I'm developing scripts. I used to have access to VMware host, but now all I have is my laptop. Not a question. Yeah, so Vagrant filled the gap. I got you. Very cool. So what Tom wrote in the chat, just for the purpose of posterity, is he wrote, my use case is that I need to spin up blank VMs while I'm developing scripts. I used to have access to VMware host, but now all I have is my laptop. There's not a question. Vagrant filled the gap. Yeah, and that's kind of where I use it too. The best use case for me really is just when I need a machine really, really fast. Before, when I needed to spin up a lab for something like that, I was downloading an ISO, which took a while because I would lose it. And then on next finishing my way through setup. And even some of the lability and some other things like that, like they don't necessarily get you a patched image, and it doesn't work as well combining something like that with a pre-existing project. So with this, I can just dump just a Vagrant file, like with this example, into my PowerShell module, and I could configure whatever I needed on that machine to be configured. And anybody else who needs to develop on that module after me can do a Vagrant up, and they can do whatever testing they need. There's some other little use cases too. There's a lot of Linux machines out there, and you can spin them up pretty easily. My blog, like the Cincinnati PowerShell Users Group blog, uses something called Jekyll, where you write it in Markdown, and GitHub will host that and generate the files for you. I found a Vagrant file that somebody else had created that referenced another Linux machine that I had nothing to do with, that I just dump into that folder. And I can CD into that folder on my local machine, run Vagrant up, and I can see how the page renders locally before I check it back in and my stuff for my blog goes live. That's pretty useful too.
have you created your own Vagrant image at all? Or do you just pretty much use what's available?
I started out with a fork off of Matt Rock's image because he didn't have WMF5 stuff in there. And I did some nasty hacks on it that kind of made it like inappropriate to contribute back, right? Like it wasn't very clean. It overwrote stuff that he had. And then eventually somebody else came along later and contributed the same change in a much cleaner way than I had done it. So I just use that from the repository now. That's, yeah, I can show you that if you wanted. I'll show you the one that I use. So here's his Packer template. And he's got them for a whole bunch of different OSs. There's a JSON template file for different situations. So he's got 2012 R2, 20 with WMF5, without, 2016 Nano, Windows 7 boxes. And then he's got some Hyper-V specific Packer builds too. And really, like, all you do is you CD into the directory and you run like that, and it builds your image. And you can also build Amazon AMIs with this. I haven't done it yet though, but I intend to do that. And also I want to do VMware images at work so that I can have a patch ready to go image every month. It's just not something I've gotten to yet. But that's Packer and not Vagrant, if that makes sense. That's the precursor.
Okay.
Anything else?
Anybody else got anything?
That's good.
Okay. Thank you very much, Alex. Appreciate it.
All right. Thank you for indulging me.
All right. Have a good night.
You too.